So as we continue our discussion in Chapter 4, we're looking in Section 8.4, looking at properties of rhombuses, rectangles, and squares. Okay, and so by the end of the lesson, or by the end of this video, hopefully you have a pretty idea as to how to use properties of these various quadrilaterals. Okay, and the reason we're talking about rhombuses, rectangles, and squares is because they are all special cases of parallelograms, which we've already discussed in Section 8.2 and 8.3. Okay, so what does it mean to be a rhombus? Okay, a quadrilateral is a rhombus if and only if it has four congruent sides. You'll notice here the definition of a rhombus is a biconditional statement. Remember, biconditional, if and only if. We talked about that in first semester. So a quadrilateral is a rhombus if and only if it has four congruent sides. So to be a rhombus, that's all that has to be true, is you have to have four congruent sides. Okay. All right. So moving forward here. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So really what it comes down to is a rhombus is a parallelogram in which you have four congruent sides. Once you know that you're a rhombus, then you know that your diagonals not only bisect but are also now perpendicular. Okay? So again, in a rhombus, the diagonals are perpendicular and they bisect each other. And finally, in a rhombus, the diagonals not only bisect each other, but they bisect the opposite angles. Okay, so if you look at this diagram down here, this diagonal bisects both of these angles. Okay, so you'll notice that this diagonal, both diagonals bisect the opposite angles. Okay, so AC bisects angle A and angle C, and BD bisects angle B and angle D. So again, a rhombus, diagonals not only bisect each other, but they also bisect the opposite angles. And now we're going to transition into what it means to be a rectangle. Okay, a quadrilateral is a rectangle if and only if it has four right angles. Okay, so here's a four-sided figure. We know that all four of these angles are right angles. Therefore, that thing has got to be a rectangle. Okay, once you're a rectangle, then we know a couple unique things. The first is that your diagonals are congruent. Okay, diagonals are congruent. So this thing is a rectangle if and only if AC is congruent to BD. All right, so again, if you're a rectangle, you have four right angles and your diagonals are congruent. And finally, a quadrilateral is a square if and only if it is a rhombus and a rectangle. Okay, so it's got properties of both a rhombus and a rectangle. Okay, so another way of saying that is that a quadrilateral is a square if and only if all four sides are congruent and all your angles are right angles. Okay, I think we already knew that, but now you can kind of see where this thing comes from, the hierarchy. A square is a rectangle and a rhombus all at the same time. So quickly in summary, a rhombus is a parallelogram in which you have four congruent sides, okay, and your diagonals are perpendicular, and the diagonals bisect opposite angles. That's all in addition to the properties of a parallelogram. Okay, a rectangle is a parallelogram that has four right angles, and once you're a rectangle, the unique characteristic is that your diagonals are congruent. And finally, a square has all of those traits of both a rectangle and a rhombus. All right, so it says for any rhombus, RSTV, decide whether the statement is always, sometimes, or never, is always or sometimes true. Draw a sketch and explain your reasoning. Okay, so we have a rhombus, RSTV. Here's RSTV, RSTV. And remember, to be a rhombus, all you have to mark to show that you're a rhombus, all four sides are congruent. That thing's got to be a rhombus now. Okay? So the question is, does angle S have to be congruent to angle V? Okay? The answer to that is yes. And how do I know that? Well, again, we've already established a rhombus is a special type of parallelogram. So as soon as I know this thing is a rhombus, that automatically means it's got to be a parallelogram. And remember, in a parallelogram, opposite angles have to be congruent. Okay, so angle S will always be congruent to angle V. So I guess my answer should not be yes. My answer should be always. Okay, so they will always be congruent. And the next question is, will angle T, okay, so let me use a different, I'm going to use green here, angle T congruent to angle V. When will that be true? Sometimes or always? And the answer to that question is it's going to be sometimes true. Okay, and as a matter of fact, the only time that's going to be true is if this thing is not only a rhombus, but more specifically, it's a square. Because the only way for these two angles to be congruent is if they're both right angles. Okay. Again, it goes back to the idea that consecutive angles in a parallelogram add up to 180. Right? They're supplementary, and the only way for two angles to add up to 180 and be congruent is if they're both 90. Okay. At the bottom here, it says for any square, is it always or sometimes true that CD is congruent to DE? Explain your reasoning. I'm not going to go too far into this, but and I'm not going to draw the picture either. But remember, in a square, all sides are congruent and all angles are congruent. Okay, and so when it says, is it always true or sometimes true that CD will be congruent to DE? The answer to that is always true in a square. Okay, because remember, a square is a rhombus, and a rhombus has 4 congruent sides. The second example says for any square, is it always true or some? Oh, I'm sorry. That was the example we just did. Okay. Skip that. All right. Is enough information given in the diagram to show that quadrilateral ABCD is a rhombus? Explain. Okay. So the first thing to note here is you can see pretty easily that this whole angle and this whole angle are both 40, so they're congruent. And you can also see that this big angle and this big angle are both 140, so they are congruent. So that automatically indicates that we have a parallelogram. Now, for a parallelogram to be a rhombus, remember, there was one of the properties that said diagonals not only bisect each other, but diagonals bisect opposite angles. And in this particular example, if I look at diagonal AC, that cuts these two angles in half. And then if I look at diagonal BD, that cuts these two angles in half. Okay, so if your diagonals bisect the opposite angles, then it is a rhombus. So the answer here would be yes, it is a rhombus because your diagonals bisect the opposite angles. You're going to notice there's not a whole, there's going to be a lot of properties that you're going to have to be familiar with. So you're going to just have to take the time to familiarize yourself with all of these different traits. Okay, example 4 says classify the special quadrilateral. So we want to be as specific as possible. Okay, so figure A here, all they tell me really is that I have all sides are congruent. Therefore, the general conclusion I can draw here, the most specific conclusion I should say, is that it's a rhombus. Okay, it's also a parallelogram, but a rhombus is a parallelogram. Okay, so that's enough there to say that that figure is a rhombus. The next figure says, if you look at part B, all of your sides are congruent and all of your angles congruent. Think about this. If all 4 of these angles, the only way that these 4 angles can be congruent in a quadrilateral is if they are all 90 degrees. Because we go back to section 1, we know that the angles in a quadrilateral add up to 360. Okay, 360 divided by 4 tells me that each of these is 90. So if I have 4 right angles, that makes it a rectangle. I have 4 congruent sides, that makes it a rhombus. So if you're a rectangle and a rhombus at the exact same time, well then what that means is that you have to be a square. Okay. And then finally, well not finally, I guess there's 2 more examples. Part C says, here's your diagram, classify the figure. Okay. Well, first of all, we know at least it's a parallelogram. We know these 2 angles are right angles, so what that automatically means is that these 2 have to be right angles because we know that opposite angles have to be congruent. Okay, so once I've established that, I have 4 right angles and it's a parallelogram. There's nothing unique about my side lengths, therefore this thing has to be a rectangle. Okay, rectangle, parallelogram with 4 right angles. The fourth example here, figure D, you notice that your diagonals bisect each other. So immediately, as soon as I know my diagonals bisect, that tells me, if you recall from section 8.3, that this thing has to be a parallelogram. And then I say, okay, is there anything more specific? Well, this guy here means that all these are actually right angles, so it means that your diagonals are perpendicular to each other. And there's only one figure that we've talked about so far that your diagonals are perpendicular to each other, and that figure happens to be a rhombus. Okay, so again, this is just getting comfortable using these properties that we've discussed throughout the video. So this last one says sketch rhombus FGHJ and list everything you know about it. Okay, well, if I want to sketch a rhombus, all I have to do is draw a quadrilateral. That's pretty ugly, but it doesn't really matter. As long as my markings indicate it's a rhombus, then it's a rhombus, okay? That thing's a rhombus. Gotta be. Okay, so what do we know about it? The figure has to be a parallelogram. Okay, I know that much, right? Because a rhombus is a special type of parallelogram. And the figure has 4 congruent sides. All right, so now what we know is, since the figure is a parallelogram, what does that mean? That means opposite sides are parallel and congruent. It means opposite angles are congruent. It means consecutive angles are supplementary. Diagonals bisect each other. And then we can go a couple steps further now. We know that the diagonals are perpendicular since it's a rhombus. And furthermore, we know that each diagonal bisects opposite angles. Okay, so these last two are really the two that are new today, okay, from a rhombus. So again, that's just the basic idea of being able to sketch a figure and knowing what makes it a rhombus. And finally, we're building a frame. I'm going to have you guys look at this on your own, and then we'll talk about this first thing tomorrow in class. So bring any questions you have about rhombuses, rectangles, or squares, and we'll take those questions before we get rocking and rolling with our class.